So now let's talk about the secant to the third power. How do I find this integral and why it is important? Because we're going to use this guy to find the integral of like t squared, square root of t squared plus 2 and so on, trig substitution. So I'll show you. The integral of secant to the third can be written as the integral of secant squared theta times secant theta d theta. Very good. So secant squared times secant. Here we're going to apply a method that you learned before that we call integration by parts. So in this method, let's take u to be secant theta and dv be secant squared theta d theta. So du, which is the integral of secant, as you learned before, secant is 1 over cosine, and then you apply the quotient rule, and then you get secant times tangent d theta, and v is equal to tangent theta. So now we're going to write this as uv minus integral v d, as you remember. Okay, what is u? U is secant theta. What is v is tangent theta minus the integral v du, tangent times secant times tangent. Secant theta times tangent theta d theta. So what happens? You end up with secant theta times tangent theta minus the integral of tangent squared theta secant theta d theta. Tangent squared can be written as secant squared minus 1. So here you have secant theta times tangent theta minus the integral of secant squared theta minus 1 times secant theta d theta. So this is my original integral, and I keep adding equality so you see where we are going. This is equal to secant theta tangent theta minus the integral. We distribute secant into parentheses. We get secant to the third theta minus secant theta d theta. Very good. So you have left-hand side. Let me use a color marker. You have your left-hand side, which is secant to the third, and you have your right-hand side. Let me write them side by side and show you what I'm going to do here. The integral of secant to the third theta is secant theta times tangent theta minus integral of secant to the third theta d theta. And here, this is going to be in front, all right? Just add the parentheses here. And you're going to distribute this negative sign, you get plus integral of secant theta d theta. So take a look. I have something on the left-hand side, and I have the opposite of that thing on the other side. So I'm going to add integral of secant to the third to both sides. And here we get integral of secant to the third theta d theta plus integral of secant to the third theta d theta equals to secant theta tangent theta plus integral of secant theta d theta. So what happens? I have the same object added to itself. I have 2 times the integral of secant to the third theta d theta, which is secant theta times tangent theta plus the integral of secant theta d theta. So just divide everything by 2. A half plus a half. But integral of secant theta, we already calculated that. This is equal to ln of absolute value tangent theta plus secant theta. So our conclusion is the integral of secant to the third theta d theta is a half secant theta tangent theta plus a half ln of absolute value of tangent theta plus secant theta. So on the exam, in your homework, if somebody asks you to prove the integral of secant to the third is this, You can take the derivative of both sides, or you can just show step by step. We can show that you know how to find these types of integrals. By practice, you feel more comfortable. So practice is the key.